Hello everyone, this is the second lesson of Chapter 9, Solving Quadratic Equations by Graphing. In this lesson, you will solve quadratic equations by solving and will find solution of quadratic equations since we will practice with graphing calculator. I'll be using Desmos for graphing calculator and I suggest you to go to desmos.com before continuing the video. Last chapter, we solved quadratic equations using zero product property. In this lesson, it will ask to find the roots. Roots are the solution of a quadratic equation. This can be found by finding the x-intercepts or zeros of the function. In another word, if you are solving a quadratic equation, you're going to find the x-intercept, which means you're finding the zeros. Another word in this lesson, we'll be using roots. Example number 1. Solve x squared minus 3x minus 10 is equal to 0 by graphing. I know last lesson we were learning about how to graph, and I believe that was good practice for you to know how to graph. On this one, you'll be using Desmos. When you go to desmos.com, you'll be start graphing. You're going to type f of x is equal to x squared, and make sure that you bring your mouse to the bottom, minus 3x minus 10, and it will graph automatically for you. If you cannot see all of them, you can always zoom out, and you can also do zoom in if you want to see it a little bit closer. In this case, as I mentioned, we're going to find the roots. The roots are the same as when you are having a x-intercept. So this is the x-intercept where my 2 points are passing through negative 2, 0 and 5, 0. So in this case, my roots are your x is equal to negative 2 or positive 5. This is the same way as what you've done using ZPP in last chapter, where if you find the factor of this and to solve using zero product property, you will find the same answer, x is equal to negative 2 or 5. Here's another example. Solve x squared minus 2x minus 8 is equal to 0 by graphing. This problem came with the graph, but if you don't have a graph, again, you can use desmos.com. When I ask you to solve, I'm looking for x values when y is equal to 0. Another word, I'm asking you to find x-intercept. So in here, I'm looking at an x-intercept as 1 point right here, which is negative 2, 0, and another one, 1, 2, 3, 4, this is 4, 0. So I know my x value has to equal to negative 2 or positive 4, which is A will be my answer. Example number 2, solve x squared plus 8x is equal to negative 16 by graphing. In last chapter, you were asked to use ZPP a lot, where you had to solve this equation by having 0 on the other end. When you are using a graphing calculator, we're going to do similar steps. It's because when you are graphing x squared plus 8x is equal to negative 16 on Desmos, you would realize that you just get one line. It doesn't change even though you zoom out. So instead of this, I'm going to add 16 on both sides. So that way I will have x squared plus 8x minus 16 is equal to 0. Where when I actually graph, I'm going to use this as f of x or y. So in here, if I draw a new graph using y is equal to x squared plus 8x plus 16, keep in mind this became positive now since I moved it. And if I get rid of this one now, you will see a nice parabola. And I'm looking for the x-intercept where it looks like if I click this point, it will tell you already it's at negative 4, 0. So if my x-intercept is at negative 4, 0, what you're going to write is as a solution, my answer is x is equal to negative 4. Here's part B. Using the same steps, x squared plus 2x is equal to negative 1 by graphing. I'm going to add 1 on both sides if you need to graph. Then f of x is equal to x squared plus 2x plus 1. When you graph, you'd realize that I have only one solution. The reason is because when you rewrite this in a factor form, if you remember, x times x will give you x squared, 1 times 1 will give you 1, where when I add them, I get 2. So when you write it, this becomes x plus 1 times x plus 1, where this is the same as when you have x plus 1 squared. So this is a perfect square case where when you're using ZPP, you only had x is equal to -1. That's why you only have one point at -1, 0. So I know my solution, unlike the other ones, this one will just have -1 as your solution. Number 3, when you're graphing, there are cases that you will not have a real roots. What I mean by real is like a real numbers. So if I use again the Desmos, when you graph, if you happen to have a linear, the reason is because of your square wasn't typed as a exponent. It looks like you're doing x times 2. So keep in mind this has to be a exponent where you could use the exponents on your keyboard, where if I type 2 like this and get rid of this one, now it's going to be a parabola. It looks like when you're graphing this one, you'd realize that I don't have any x-intercept. And since it's going to be upward parabola, where this is going to be my minimum, even though you zoom out, you will not have any coordinates on the x-intercept. So my answer will be no solution. And also, we use a symbol for no solution. If you draw the 0 with slash like this is something that they will use a lot, especially in this textbook. So just keep that in mind, that this will be a equivalent to no solution. Part B, if you solve x squared plus 4x plus 5 is equal to 0, you're just looking for, are there going to be any x-intercept? In this case, again, since there's none, there will be no roots. So my answer will be D, where this is the same as when you have no solution. Sometimes I just write NS. Hope that's okay with you. So 3 different types of solution when you're graphing a quadratic equations. One, you could have 2 real solutions when they are intersecting with 2 points on the x-axis. Another one is when you only have one solution. This is the case of perfect square. For example, when you have a plus b squared, or when you have a minus b squared. There will be cases when you don't have any solutions, so they're not intersecting with your x-axis. So this is a case of no solution. Keep in mind, this is the symbol that we're going to use. And this was the case when you could not factor. Do you remember what it was called when you cannot factor anymore? It was called prime, and to be more specific, it was prime polynomial. On this textbook, they're asking you to estimate, where in this video, we're not going to do any of the estimate. Instead, since we're using the Desmos, we're going to find exact value. For example, solve x squared minus 4x plus 2 is equal to 0 by graphing. If integral roots cannot be found, estimate the roots to the nearest tenth. When you're using the Desmos, it will tell you the value right away, but just double check to see if it's nearest tenth. So that's something that will be careful. Here's a graph of this situation. When I graph it, again, you're looking for the 2x intercept. When if I click it, it will tell you the exact value. The first one is at 0,586. The second one is at 3.414. When you round up from 100th, this is over 5, so I could write 0.6. Or for the second one, if I round up, since 1 is less than 5, I cannot. I'll just keep it as it is, so x is equal to 3.4. The reason I have a table written as a title is because the textbook wanted you to estimate. However, since you're allowed to use graphing calculator on the assessment, I'm just going to practice with using Desmos, or hoping that you're using your graphing calculator. Part B, solve x squared minus 5x plus 1 is equal to 0 by graphing. For the same reason, since this one is already providing a graph, well, let's see if we can find the best option in here. It looks like this point right here and that one are going to be your x-intercept, where this is definitely less than half. Where for the next one, this one is at 1, 2, 3, 4. It's less than 5, so I know that anything above 5 should not be the answer. I would go with either B or C. And this is not the best example, I guess, because they are so close. I guess I have to graph it actually, just to double check. When I graph x squared minus 5x plus 1, it looks like the first point is at 0.2 and the second one is at 4.7. So my answer is C. The real world example number 5. Please pause this video for a minute to read the instruction on your own. When you are given with the equation, they're asking you where h is the height of the rocket in feet and t is for the seconds. Approximately how long was this rocket in the air? I want to know by using graph. So if I graph this, as you see, it's not showing me anything. The reason is because this calculator does not recognize your t. I have to change it with the x. And then the reason it's because it's a straight line. Let me zoom out. It's because it looks like I have a parabola. Do you see the two lines? So let me zoom out as much as I can. So it looks like over there is my vertex. That's going to be my vertex over there. And if I'm looking at it, the 2x-intercept of this point is from 0, 0 and 15.625, 0. And remember, instead of t, I use the x, so then h will be your y. And since you're asked how long it was in the air, if my graph was forming a parabola shape like this, whatever this maximum is, I'm just looking for what is my range from the 0 up to this point where the rocket was in the air. So since if this was 15.625, my answer will be 15.625 seconds. And this was found by using the graphing calculator and by finding the x-intercept. Here's the last problem. Again, if you could take a minute to read a situation. Here's an equation that you're going to use where h is the height of the ball in the feet after t seconds. Just like what I did earlier, since the graphing calculator will not recognize h or t, I'm going to use h as your y and t as your x. Then here's a graph again. I know that it looks like two lines. However, if you zoom out, it should be a parabola on the top. Since they were asking you again how long was the golf ball in the air, I'm asking what is, if it started at 0, how long was this second? In this case, it looks like it's a 7.5, so my answer will be approximately 7.5 seconds. This is the end of the lesson. Thanks for learning with me. If you have any questions, please leave a comment.